So this is really important. When we teach about science, when we teach about atoms and bonding and things like that, we often talk about atoms being happy because they get what they want, and what they want is a full outer shell of electrons. However, atoms can't be happy and they can't want anything because they're inanimate objects. It's a bit like saying a table wants people sat around it, or it's happy when there's food on the table. The table isn't happy. A table can't be happy, and an atom can't be happy either. So it's really important that you don't talk about what an atom wants or what will make an atom happy in any exam questions. If they don't have a full outer shell of electrons, then they are less stable than if they have a full outer shell of electrons. So atoms move towards being more stable, so they move towards having a full outer shell of electrons. They do not want anything. So we've got 3 atoms here, sodium, chlorine and argon. We're asking which is the least reactive and why? Well, argon is the least reactive because it has 1, 2, 3, 4, 5, 6, 7, 8 outer shell electrons. There are 8 outer shell electrons, so that is a full outer shell. So it is stable. Chlorine has 1, 2, 3, 4, 5, 6, 7. So that needs to gain 1. And sodium has 1, so that needs to lose 1 in order for it to become as stable as it possibly can be. What do sodium and chlorine need to do to achieve a stable electron configuration? Well, sodium needs to lose 1 electron and chlorine needs to gain 1 electron. Maybe this 1 electron can transfer from sodium to chlorine, and that will make both atoms more stable. And in fact, that's what happens, and that's what this lesson's about. 118 elements in the periodic table, currently. Only 7 of them have a full outer shell of electrons. And if we look at the periodic table, they're the ones that we find over here in group 8 or group 0. They're known as the noble gases. Probably not a shock for you to find out that they're all gases, and the word noble basically suggests that they are less reactive, and they are. They don't react very readily with anything because they have this full outer shell of electrons, so they don't need to gain or lose electrons, and gaining and losing electrons is how atoms bond. Okay. The noble gases are helium, neon, argon, krypton, xenon, radon and oganesson. All other atoms are unstable, and they will react chemically until they've reached a full outer shell. Once they have reached a full outer shell, they are then more stable, and they will become unreactive, or less reactive, certainly. And they do this by bonding to other atoms, and that makes molecules that are stable. So, for example, you can have chlorine from group 7, and you can have sodium from group 1. Sodium is a metal. It reacts with air. Chlorine is a non-metal. In fact, it's a gas. And it's highly toxic. A couple of lungfuls of chlorine, and at the very least you need to go to hospital, probably be dead though. However, if we bond these 2 very reactive materials together, we get NaCl, which we know as salt. It's table salt. It's the stuff that we put on our chips. Things on the left of the periodic table, in groups 1 and 2, readily lose electrons. Things that are on the right of the table that aren't quite the noble gases in group 0, so that's in group 7 and group 6, readily gain electrons. Now, things in group 3, 4 and 5 also do get involved in this, as do some of the transition metals. However, all of the questions you'll be asked in GCSE about ionic bonding, which is what we're looking at, will be about group 1 and 2 metals and group 6 and 7. There's 3 main types of bonding, and ionic is what we're looking at today. It's always between metals and non-metals, so if you've got 2 metals or 2 non-metals, it ain't ionic bonding, and it involves electron exchange. It involves an electron going from one atom to another, producing ions, hence the name ionic bonding. So this is a Dawson cross diagram. This is the reaction that we've just looked at on the previous slide, where we've got sodium, reactive metal, and chlorine, a reactive gas, that when one electron is transferred from the sodium to the chlorine, we produce sodium chloride, table salts that we're familiar with. The reason that we draw dots on one atom and crosses on another atom is purely to show where the electrons have come from. We could have drawn the crosses on the sodium atoms, and we could have drawn the dots on the chlorine atoms. It really doesn't matter. It's purely there to show where the electrons came from. They are the same electrons, or the same type of electrons. There's no difference between the red dots and the blue crosses. They're just from different atoms. If you've got an element from group 1 of the periodic table, it will lose 1 electron. If you've got something from group 2, it will lose 2 electrons. Similarly, if you've got something from group 7, it will gain 1 electron. If you've got something from group 6, it will gain 2 electrons. It has to do that in order for it to become stable. So here we have a group 2 atom, or group 2 ion at this point, of calcium, and it has lost 2 electrons. Now each of those electrons have gone to a different chlorine atom to make 2 chloride ions. So the calcium ion had to lose 2 electrons to have a full outer shell. The chlorine atom had to gain 1 electron to have a full outer shell. We've got the opposite situation here, where we've got lithium, which each needs to lose 1 electron, and we've got oxygen, which has a gap that is 2 electrons. It needs 2 electrons to make a full outer shell. So what we have here is we need 2 lithium atoms, each losing 1 electron to oxygen. Ionic compounds form ionic lattices. So here we've got sodium chloride, and we've got green chlorine atoms, chloride ions, and grey sodium ions. And you can see that each chloride ion is surrounded on each of the 6 sides by a chloride ion. Similarly, each chloride ion is surrounded, there would be another one out here, on each side by a sodium ion. So we can form this ionic lattice. Now this ionic lattice can literally go on forever. So it can be what we call a giant ionic lattice. It can be as big as we want. The question was to complete these dot and cross diagrams. We've got the first one that's done for us. We've got sodium and chlorine. Well, sodium loses this electron to chlorine. So we can see here on the right hand side, sodium has lost the electron to chlorine, and that has made sodium chloride. Potassium chloride, well, we need to fill in the chlorine atom's electrons. So we know that's got 7 outer electrons, and we are going to 3, 4, 6, 7, change to red, and this electron is going to move to here. Oops. It's going to go just there. Okay. Next one, calcium oxide. Again, we're going to draw in our oxygen electrons because they don't move. Our 2 calcium electrons both move across here, so we get 2 electrons there, and we get calcium oxide. Oh, I should have written KCl there for potassium chloride. Potassium's got a weird chemical symbol. And then we've got magnesium oxide, so we need to fill in oxygen on both sides, and because we've got it just above, we can fill that in as 4, 5, 6. We're going to keep that the same over here. Okay. And again, we're going to have these 2 electrons from magnesium move across. So we get MgO, magnesium oxide. We need plus and minus, because there's 1 electron moved. 2 electrons have moved, so 2 plus and 2 minus. And again, 2 electrons have moved, 2 plus and 2 minus. So using the periodic table on the next slide, can you fill in the blanks and predict the formula of the compound? And this is a little bit harder. Elements in group 1 have 1 outer shell electron, so we can actually find out the elements in group 1 are sodium, lithium, potassium. So each of those has 1 outer shell electrons. Elements in group 2 have 2 outer shell electrons. So calcium's in group 2, beryllium, magnesium are all in group 2. So they have 2 outer shell electrons to lose. Elements in group 6 have 6 outer shell electrons. So they need to gain 2 electrons. So sulfur, oxygen. Those all have to gain 2 electrons. And elements in group 7 have 7 outer shell electrons, so they need to gain 1. So we've got chlorine, fluorine, 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 fluorine. Okay, so where there is 2 in this column, we need to lose 2 electrons. Where there is a 2 in this column, we need to gain 2 electrons. So where we need to lose and gain the same number of electrons in both columns, we can just write out the formula with the metal and then the non-metal. So that'll be NaF, sodium fluoride, BeS, beryllium sulfide, LiF, lithium fluoride, Mgs, magnesium sulfide, KCl, potassium chloride, and that's all of them. Okay, now where we've got a 2 and a 1, what we need to do is we need to have the same number associated with each of the elements. So we've got a 2 here for calcium, we've got a 1 here for chlorine. So what we need is we need 2 chlorines. Okay, so we write down Ca, calcium, because we always write the metal first, and then because we need 2 chlorine atoms to be made into chloride ions, we write Cl2, so CaCl2. Same here with beryllium and fluorine. Be, beryllium, because we write the metal first, and that's got the number 2 associated with it. F, fluorine. Well, there's only a 1 there, so we need 2 of those. So BeF2. Okay. Next one, same again. We need 2 fluorine atoms for 1 magnesium atom. So we get MgF2, magnesium fluoride. Now the others are all the other way around, so we write them the other way around, where we've got 1 oxygen atom that needs 2 electrons. We've only got 1 electron to give away for each lithium atom, each sodium atom, and each lithium atom again. So what we need this time is we need Li2O, Na2O, and Li2S. I will leave you to have a go at the exam questions.